Last class we discussed the Putco Parity, which is a very basic and important theorem in option valuation. I just want to go through the basic process, how we got this result. So basically we compared two kinds of portfolios, right? So we compared call plus bond and put plus equity. And then we find out these two different portfolios will give us the same payoffs no matter what happens in the future, right? So you can see that under these two different cases, the payoff from these two different portfolios is always X or ST, right? So the important thing is they're equal under different cases. So based on this result, we would know that if two portfolios always give you the same payoffs in the future, then we would know that their present value should be the same. So this implies this Putco parity, that is, the present value of this put plus equity equals the present value of call plus bond, right? So this leads us to this important result, that is C plus the present. So C plus the present value of X equals S0 plus P. And C is the call price, X is the exercise price, S0 is today's share price, and P is the put price. And then we also talk about a more general form of Putco parity, that is when the share is paying dividend, right? So if you're having a dividend paying equity, what you will get is a result like this. That is C plus present value of X plus present value of D equals S0 plus P, right? Okay, great. And then we started this section on general rules on option values. So essentially we want to discuss some properties of option values. Of course, these are just properties, so we're not precisely trying to pin down option values. However, you can see that you can get some general results here. That is, option values will generally follow these rules, right? So first we decompose option value into two components: intrinsic value and time value. Intrinsic value is pretty easy to understand, right? Because it's really the profit you could get if you exercise this option immediately. And then time value, basically it discusses some sort of volatility value. That is, if the option still has time to expire, then something favorable could happen. So this will give your option higher value. Then we ended with this page. That is, we tried to discuss the determinants of option values, but we ran out of time, right? So we basically discussed the first three variables. That is how stock price, strike price, time to expiration would affect the value of American calls and American put. And we haven't discussed volatility. So you can see that if volatility is higher, both calls and puts will be more valuable. And how do you understand this? Let me give you a numerical example which will tell you why this is the case. So let's say we're looking at a call, right? Let's say it's 1 year, right? And let's say the call has an exercise price of $100. And then let's say we have two cases. The first case, the stock price could be $90 and 150 with, let's say, with 50% chance and 50% chance. And then we have scenario 2, right? Case 2. The stock price would be, let's say, 80 and 160. So the two values would happen in the future with equal probability. Now, if you compare these two scenarios, you can see that the expected value of the share price would be the same, right? So the expected value of the price here is, sorry, it's not 70, it's 120, right? So it's always 120. However, if you think about this from the perspective of volatility, you can see that case 1 has smaller volatility, right? So if you look at volatility here, it is actually smaller. Why do we have smaller volatility? Because you can look at the variation here. In case 1, the variation or the range of the share price is $60. And the range in the share price in case 2 is $80, right? So it's 160 minus 80. So you can see that volatility in case 2 is larger. Now, let's look at the call price. So under case 1, the payoff of the call is either 50 or 0, right? So if the stock price is 150, then you would actually want to exercise this call, so your payoff would be 50. And if the share price is 90, then in this case you would not want to exercise, so the payoff would just be 0. And by the same reasoning, you can see that under the case if the stock price is 160, then you exercise your call, you would get $60. Now here, again, you get 0, right? Now, what's the caveat here? The caveat here is you wanted to look at the upside, right? What you can see here is the payoff for the call under case 2 is actually larger, right? So we know case 2 has larger volatility. Essentially, this means call is more valuable if volatility is larger. And you can make the similar argument about the relationship between put and volatility. And you will still get the same result. That is, a put would become more valuable if volatility is larger. So what's the intuition here? The intuition is when you have a call, you have a limited downside, right? Because no matter how bad the share turns out, the call price will just be 0. It won't become negative, right? So you can see that there is a lower bound on your downside. You won't get worse than 0 payoff. However, you have unlimited upside. So if the stock price increased a lot, then the payoff to the call will be very large. So this basically implies you will prefer volatility if you have a call, because higher volatility means there is more upside, right? So this explains why higher volatility leads to more valuable calls and puts. Now, what about the risk-free rate here? So what I can see here is the risk-free rate will actually make call more valuable and to make put less valuable. Right? How do you get this result? The explanation to this result is think about the exercise price, right? So you can see that for call, if risk-free rate is higher, this implies the present value of exercise price is lower, right? And for a call, exercise price is the price you have to pay to get your share. So you can see that if risk-free rate increases, the present value of exercise price becomes lower. This essentially means you could buy shares at a lower price, right? So this will increase the value of your call. And then what about put? Well, for put, it's the opposite, because if you're having a put, the exercise price is your selling price. So you want this exercise price to be large. However, if risk-free rate increases, this will decrease the present value of your exercise price. So your trade from put becomes less profitable. So put would become less valuable, right? So that's why you have a minus sign here. Now, what about dividend? Dividend is actually easy to understand. Dividend, paying out a dividend, will make call less valuable and will make a put more valuable. Why? Well, again, think about the profit from your trade, right? Or you could just think about the intrinsic value, right? So the intrinsic value for a call is stock price minus X, the exercise price. A general result in finance is if a firm pays out a dividend, then its share price will decrease. Theoretically, if the firm pays out $2 dividend, then its share price should decrease by $2. So this implies if there is a dividend, then the share price would be lower. So this reduces the profit of your call. So your call will become less valuable. Now the opposite would happen to put, right? Because for a put, the intrinsic value is given by X minus S. That is exercise price minus share price. And if there is a dividend, this means S would be lower, right? So if share price decreases, then the profit from your trade would be higher. So put would become more valuable, right? There is a little caveat here. If you look at the European calls and European puts, they have the same result as their American counterparts, but the only difference is here. So the effect of time to expiration on European call and European put is ambiguous. So how to understand this? Well, the reason is there are two forces to affect the value of call and puts when you're thinking about time to expiration. The first is the volatility value, right? So for a European call and put, if there is a longer time to expiration, then it means the volatility in the longer time horizon will be larger. So European call and put can be more valuable. However, there is this offsetting factor. That is, if you have a longer time to expiration, the present value of your payoff will be lower, right? And you can imagine that sometimes the second factor would actually be more important. That is, the lower present value from longer time to expiration would become the more dominant factor. In this case, a longer time to expiration will actually reduce the values of European calls and puts, right? I mean, you can actually think about this in an extreme case. You can imagine that you have a European call and its time to expiration is infinite. Now, what is the present value of this call? It's always zero, right? Because it has infinite time to expiration, right? So it's a valueless call if you have infinite time to expiration. So that's why you will get a question mark here. You cannot really tell how time to expiration will affect the value of call and put. Okay, now let's move on to the next topic. This topic is about general bounds on option value. So what are we trying to achieve here is we want to understand if we can find some universal upper bound and a lower bound for calls and for puts. Now, let's first look at calls, right? The first result is for both American calls and European calls, there is an upper bound. The upper bound for a call is the share price. That is, if you're looking at a call price C, if the current stock price is given by S0, then the price of call has to be smaller than the share price. Now, why do you get this result? Well, because think about this. What is a call? A call essentially gives you the right to buy shares, right? However, if the current share price is S0, there's no way this right to purchase this share could be worth more than S0, right? So you will get this first result. That is the upper bound for a call price. Now, what about lower bound? Well, lower bound is actually pretty easy to understand here. So we have learned about the Putco Parity, right? So according to Putco Parity, C equals P plus S0 minus PVX minus PVD. And then an important result is the call price and the put price cannot be smaller than 0. Right? This is easy to understand because the lowest payoff from a call or from a put is just 0. So if you discount these zeros, you will still get a present value of 0. So there is no way the call price and the put price can drop below 0, right? So this basically implies if the price of put is larger than 0, then this implies the following inequality. Right? So this gives us the lower bound. That is, the price of call is larger than the stock price minus the present value of X minus the present value of dividend. Of course, there's another caveat here. We know that the call price cannot be negative, right? So we have to add this additional requirement. That is, call price is larger than 0. So the call price has to satisfy these two lower bounds. And we could actually write this in a more compact form, right? So we could use this max sign here. That is, C has to be larger than the max between these two values. I hope you have some basic understanding how this max sign works. Right? So for example, max AB. So what is max AB? It's essentially A if A is larger than B, and it's B if A is smaller than B, right? So you could actually write this compact form into this non-compact form, which could possibly give you better idea what is going on here. Now, in the case of this lower bound, what you can see here is what you can see here is max S0 minus PV X minus PVD 0, right? This essentially implies C is larger than 0 if 0 is larger than S0 minus PVX minus PVD, right? And C is larger than S0 minus PVX minus PVD if 0 is smaller than this quantity, right? Okay, now what about put? Well, first, for American put, the the put price has to be smaller than the exercise price. The reason is because a American put option gives you the option holder the right to sell one share for X, which is the exercise price. So there's no way you would pay more than X to gain the right to sell a share at a price of X, right? And what about European option? Well, for European option, we can actually get a better or a tighter upper bound. So if a European put option has the exercise of X, then we know that at maturity, the option cannot be worth more than X, right? So this implies that the price of the put has to be smaller than present value of X. Now we could also again talk about the lower bound on the value of the put. Sorry, this one should be put. So what we will do here, we will again use the Putco parity, right? So we know that P equals C plus PVX plus PVD minus S0. This is just the Putco parity. And we know that C has to be larger than 0. So we will have the following inequality. Right? So this will give us the lower bound. Again, we know that put price cannot be negative. So we have to add this additional requirement. And then if we combine these two requirements, we will have this formula here. So the requirement here is, the requirement on the upper and lower bound here is, as long as you can remember what are these upper and lower bounds are. So generally definitely I will not ask you to prove or to derive these bounds, right? You will not be asked about these proofs. Okay, next, let's talk about a very important and interesting question. That is early exercise on American options. So this is actually a pretty intriguing question, right? Think about this. If you compare American options versus European options, right? Their only difference is American options give you this huge flexibility. That is, you can exercise your option anytime on or before the expiration date. But for European options, you can only exercise your options on the expiration date, right? So you have much less flexibility if you have in European options. Now, you might wonder, well, I can't do early exercise, right? If I have American options, but should I, right? Should I exercise early on my American options? Well, this is actually somewhat complicated. It really depends on different scenarios. So I will just give you the result here. So if you have American call, and if this call does not pay dividend, then you should never early exercise. If you want to close your call position, you should just sell your call, right? If you have American call and before expiration, the stock will pay you a dividend, then maybe you will want to exercise this call and to get that dividend. Next, if you're having American puts, then no matter whether there is dividend, possibly you will want to exercise your puts early. So that's the preview of our results. Now let's look at these results one by one. First, the case when you're having a American call and there is no dividend. So the result is, if there is no dividend, then you should never exercise. I have some proof here. So you can see that I have this one-page proof. Clearly, I'm saying it's not required, but if you have time, I would recommend you to look at this. It's actually a interesting, simple proof to tell you why you should never early exercise your American calls. So without proof, I give you the result, and I will discuss what kind of implications under this result. So think about this. So there are actually several implications, right? So let's say now you have American call, and you wanted to close your position. So this basically means if there is no dividend before its expiration date, the only choice is you should sell it. You should sell this call to close your position. You should never exercise your call, right? So this is first useful guidance when you're actually trading options. The second is, you might wonder, is this assumption realistic? Because to get this result, you have to assume there is no dividend. This assumption is actually very realistic because generally a firm will only pay you dividends like every quarter, right? So you will get 4 dividends per year. And this implies for a lot of options, especially if you have a option with like 1 month time to maturity, it's highly possible that during the next month, you will not get your dividend payment, right? So this basically means as long as there is no dividend before expiration, then you could use this result. So this result applies to most short-term options. Now, the third implication, which is a very important one, this means if you will never exercise American call early before its expiration, this basically implies the right to exercise early is worthless, right? Because you will never want to use this right. So this right to exercise early has no value. So what's the implication here? The implication is the value of American call without dividend equals the value of European call without dividend. Because why generally American options are more valuable than European options? It's really because American calls give you this option to exercise early. But now, if you will never exercise early, so the exercising early choice means nothing to you. This implies that as an investor, you will consider American call and European call the same. So the value of American call should be equal to the value of European call, right? Now, this will imply that the valuation formula, which applies to European call, will also apply to American call, right? So this will actually greatly simplify our life because in the future, you will learn several valuation methods, such as binomial pricing and risk-neutral pricing and Black-Scholes formula. And all these results can be directly applied to American calls as long as the call does not have a dividend. Even these results are derived based on European calls. Right? Now, what about the more realistic case? That is, if the stock pays you dividend, now you might want to exercise early. The basic intuition behind this result is if the stock pays dividend, then there is this positive cash flow. So basically, maybe you will want to exercise the call and to get this dividend, right? So the dividend is the only driver of this possible early exercise. Now, what about a put? So the result here is you might want to exercise your American put options sometimes, right? No matter whether there is dividend or not. So the second result is you're more likely to exercise early if the share price is already very low. So what's the intuition for this result? Well, because share price cannot drop below zero. So you can think about a very extreme case. Let's say you have a put option. Let's say it's a 1 year put option. And after 1 month, the share price drops to zero. And let's say this put option has an exercise price of $10. So you can see that if you exercise this option now, right, you will get $10 profit, right? That is the exercise price of 10 minus the share price of 0. So that's your payoff if you exercise this put option now. Now let's say if you want to wait. If you wait for 1 more year until this option reaches its expiration date, what's your payoff? Well, it's still $10, right? Because there's no way this stock price can drop below 0. So you can see that a $10 today versus a $10 in 1 year. Sure, you will prefer $10 today, right? So you can see that that's the reason why you want to exercise early, because you want to get your payoff today. You don't want to wait. You're impatient. The third result is you're less likely to exercise early if there is dividend. The intuition behind this is if a stock pays dividend, the stock price will decrease. And if you have put will be more valuable if the share price decreases. So you will actually want to wait until the dividend is paid out, until the share price drops because of this dividend, right? So that's why you would want to wait if there is dividend. And you can see that we have a picture here which tells you that, so we're focusing on this picture on the left hand side. So we're looking at this American put value. American put value is given by this curve. And this distance is given by this time value. And this straight line gives you the intrinsic value. Right? What you can see here is as the stock price decreases, the time value shrinks. Right? If stock price decreases to S star, which is a very low price, so it's a low stock price. At this stock price, what you can see here is intrinsic value, that is, the line overlaps with the curve, which means here put value equals intrinsic value. There is no time value left, right? So this basically implies you will want to exercise in this region, right? You will want early exercise because there is no time value. If there is no time value, it means there's no need, there's no benefit for you to wait. Okay? So you will just immediately exercise your put. Again, you have this proof here. Again, it is not required, but it's useful if you have time just to read this. Now let's look at a very simple example. So let's say General Electric went ex-dividend on December 22, 2005. Oh, maybe you have not learned about ex-dividend if you have not taken corporate finance. So ex-dividend day. So basically you can see that this December 22, 2005 is the ex-dividend day. So basically it means that, so if there is this ex-dividend day, it means that on this day or after this day, if you buy this stock, you will not get dividend, right? So it basically means if you want to get the dividend, the latest to purchase this share is 1 day before this ex-dividend day, right? So you can see that's why the problem says only equity holders on the previous day are entitled to the dividend. Let's say the dividend amount is 0.25, and the following table lists the quote. So we're talking about this table here. Lists the quote for the options on December 21, 2005. From the quotes, identify the options that should be exercised early rather than sold. So if you exercise early, right, you will get a payoff. If you sell it, you will get a price. So essentially you want to compare the payoff from exercise early versus the price you can sell. So let me just give you a example on the call, right? So let's look at the first guy here. So let's look at this let's look at this 26 January call. Okay, maybe I should talk about this notation here. 06 means year, so it's 2006. January, of course, just January. This one is exercise price, right? So it has $10 exercise or strike price. This GEABE is essentially the name of this option. And now let's say it has a bit of this. So if you want to sell this call, right? So if you sell, then let's say you submit a market order, right? Let's make this simple. Let's say if you sell a market order, then you will sell the call at the bid price. So the price would be 25.4, right? So that's your benefit. So this is sell. Now what's the payoff from exercise? So let's say you want to exercise this. So if you exercise this, you will have to pay its exercise price, right? So you will pay $10. What is the market price? So its market price is here, 35.52. So if you exercise, right, your profit would be $25.52. In this case, you can see that the exercise price is larger, right? Sorry. In this case, you can see that the profit or the payoff from exercising early is larger compared with selling it. So in this case, you could exercise early, right? Of course, you can see that in this case, we are talking about a share which pays you dividend, right? So in this case, it's possible you will want to exercise early. Okay, now let's pick a different one. Let's pick this guy. So it's a put. Let's say if you wanted to exercise early. So let's say if you sell this put. Well, this is easy, right? Your payoff from the selling put would be, so let's say you would just meet this bid price. So it's 0.3. Now, if you exercise, now it's a put. So if you exercise, you will sell at the exercise price. So it's 35, right? So this is your exercise price minus the market price. So what is the market price? 35.52. Oh, in this case, you will not want to exercise, right? Because because it's out of money. So in this case, you would definitely not exercise, right? Where you could say because it's out of money, so the payoff from exercise early is just 0, right? So in this case, you won't exercise early. Now let's see what kind of answer we have here. So let's see. So the answer says the holder of a call option on G stock with a strike price of 22.5 or less is better off exercising it. Okay, so let me see what's the answer here. So it says these options, you're better off by exercising early. What about a put? So the answer says for put, you should never exercise early, right? That is, the answer is for these call options, marked in red, they should be exercised early. All other options, you should not exercise them early, right? Of course, you could actually do the calculation yourself. You could verify for each option and see or compare the payoff you can get from selling it versus the payoff you can get from exercising it early. Then you could see why only these 5 call options marked in red should be exercised early. Okay, now let's talk about option valuation. So there are 3 major option valuation techniques. Now we talk about the first one, which is the binomial option pricing. If you have taken corporate finance too, possibly you have learned about this. In previous years, I never discussed option valuation because it's actually quite complicated. But I think it's actually very important topic in learning options. If you tell other people that you have learned about options and you have taken lectures on options, but you have not learned about option valuation, I think this would sound a little bit of not good, right? So let's start with the first methodology, binomial option pricing. We will mainly learn about this using examples. I think example is a good way to learn option pricing because you could learn the process and do some practice yourself. So now let's see what we have here. So here we have a call. And this call is based on a share and it's today's price. So this is today's price. So the today's price is $100. And after 1 year, right? So after 1 year, the stock price could be 120 or 90. Now, one thing you can see here is you don't have probabilities. You only know the possible results, 1 to 0 or 9, 0. But you don't know what's the probability of getting 120. Right? Now, let's assume this call has an exercise price of 110 and its time to expiration is 1 year, and we fix this risk-free rate at 10%. Our task is, how can I find out this C? What is this call price? Right? Obviously, you can see that if the stock price is 120, the call will give you a payoff of 120 minus the exercise price, which is 10. If the stock price is 90, you will not exercise the call. So the call is out of the money and the payoff is just 0, right? Now that's the basic or the numbers we have here. And to find out the value of this call, we will talk about two approaches. The first is replication. The second is hedging. If you have learned about, if you have taken my Corporate Finance 2 class, possibly you have learned about this, replication. But unless you have taken advanced corporate finance, I would guess generally you have not learned about hedging. Okay, so let's look at the first approach, that is replication. Okay, let me first talk about the general idea. So the general idea is like this. We will use a bond and a portfolio of bond and equity to replicate the call options payoffs. And if we can successfully replicate the call options payoffs, then we could use the value of our portfolio as the value of the call. That is, if bond plus equity has the same payoff as the call, then the present value of the bond plus equity has to be the same as the present value of the call. This means we could use the present value of the bond plus equity as the call price. So that's the general idea. Okay, now let's see how could we replicate the payoff. So let's say to replicate the payoff of this call, you will build a portfolio. You could call this as replicating portfolio, right? So you will build a replicating portfolio. And you will buy some stocks and buy some bond. So this is a portfolio of stocks and bond. To be more specific, you will buy delta shares of stocks and you will invest in $B in the bond. Of course, now we don't know the value of the delta and we also don't know the value of B. We have to solve this. Now, our purpose is we want to use this replicating portfolio to replicate the payoff of this call. And we have learned the payoff of this call is either 10 or 0, right? So we just need to replicate these two numbers. Now, how do you replicate these two numbers? So you use these two equations. Let me explain how do you get these two equations. Let's look at these. Let's look at these numbers. So I have to remove these middle term exams. Okay, now let's see. So remember, you have a portfolio, replicating portfolio of delta shares and $B of bond, right? And you want to make sure that this portfolio has the same payoff as the call. So what you can see here is if stock price is 120, then the value of your portfolio is 100 times delta plus B times, I think it's 10%, right? And this has to be equal to 10. Similarly, if the stock price is 90, now the replicating portfolio has 90 delta plus B times 1 plus 10% equals 0. So this is a joint equation, right? You have two equations with two unknowns. Right? You have two unknowns and two equations. So of course you can exactly solve delta and B. So here, this is the joint equation to solve delta and B. And you could solve delta equals 1 over 3 and B equals minus 27.27. You might want to know how can I solve delta and B. So let me show you. What you're gonna do is, let's call this equation 1, equation 2. What you're gonna do is you will use equation 1 minus equation 2. And you can see that this part, this B part will just cancel out. And equation 1 minus equation 2 will give you 30 delta equals 10. So delta equals 1 over 3, right? And then after getting delta, you can plug in delta back to equation 1 or 2. For example, if I plug in if I use equation 1, right? I will get 1 to 0 times 1 over 3 plus B, 1 plus 10% equals 10. So this implies B equals, I think it's minus 30 divided by 1.1, which is minus 27.27, right? So make sure you understand how to solve this. Now, after getting delta and B, we can now finally find out the price of the call, right? Well, the idea is because this replicating portfolio has the same payoff as the call, then the present value of this replicating portfolio will just equal to the call's price, right? So what is the present value of this replicating portfolio? Well, you have 1 over 3 shares of your equity, right? And you can see that the stock price is just 100. So it's just 1 over 3 times 100. And then this B is minus 27.27. So you could just plug in this number here. So this gives you the call's price, 6.06. Make sure you understand this process, right? How to calculate these numbers. And you should also need to understand what's the underlying reasoning, right? Why do we do this? Okay, so here is a general formula to calculate call price using replicating portfolios. So let's say we use CU and CD as the call options value when the stock goes up or down. And we use US0 and DS0 as the equity price. So US, I have to say this is terrible notation, but I'm basically following the textbook. So what is US0? US0 here, U basically means up, right? So it's this higher share price. So this is US0. What is DS0? D means down. So it's the lower future stock price. So this is DS0. And what is CU here? This is CU. That is the call payoff if the stock price is up. And this is CD. So now we could actually just directly plug in numbers to find out what is delta, what is B. For example, we could try to use our examples numbers. So CU is 10, CD is 0, and US0 is, I think it's 1 to 1, sorry, it's 1 to 0 minus 90, right? So it's 1 over 3. And B is, you can see that B equals CD, that is the call option payoff when the share price is down. So in this case, we know it's 0. And ST is okay, this is bad notation. I should not use SD here. So it's better to follow this notation. So to make it consistent. So here DS0 is the share price when the price is down, right? So you can see that you should use 90 here. And delta is 1 over 3 and 1 plus 10%. So again, this gives you minus 27. In the exam, you don't need to exactly follow these different, these complicated different process, these equations. It's good if you can solve this, right? In the exam, you can directly plug in numbers using this more general result. However, make sure you understand what is CU, what is CD, what is US0, what is DS0, right? Now, let's talk about the second approach, which is the hedging approach. So I think this is the first time we talk about hedging. Hedging is a really important tool in risk management. It's not the first time. So when we talk about immunization, it's actually a hedging technique. Hedging generally means that you want to use some process, use some procedures, use some techniques to remove or to manage your risk. A very typical example, at least in this lecture, is if you use hedging, then your portfolio will give you the same kind of return no matter what happens. So let's just use this basic definition of hedging. That is, the portfolio value will be the same no matter what happens, right? Okay, now let's say you wanted to hedge your share. You want to hedge your equity position, right? So let's say you have one stock, okay? Let's say you have one stock. You have one share. However, you can see that there is risk in your position because there is uncertainty in the future. It's possible the stock price would be 120. It's also possible the share price would be 90, right? So there is a variation. There is this uncertainty in the future. You want to do the following thing. You want to hedge against this uncertainty. You want to hedge against this risk. How do you do this? Well, you will actually short sell some call options to hedge against the risk in your equity position. That is, you will write some call options. So to hedge, you will write calls. You might wonder why writing calls could hedge against the risk. Well, you will see this very quickly. So let's say you want to hedge to write some calls, But the problem is how many calls should you write, right? So you really don't know how many calls. So let's assume you will write X calls. Of course, you want to solve this X. Now, by the definition of hedging, if you're hedging, you want to make sure the value of the portfolio stay the same no matter what happens. That is, your portfolio of one share and calls should give you the same payoff, whether the share price is 120 or the share price is 90, right? So let's write this out using a very simple equation. If the, okay, sorry, I forgot to mention, you will write X number of calls with exercise price equals 110. Now, if the stock price is 90, what is your portfolio value? Well, your portfolio contains one share and X number of calls. So you will actually have $90 because you have one share, and the value of one share now is $90. Now, what is the value of your call options? Well, if the stock price is 90, it's actually below the exercise price of 110. So the option buyer will not exercise the call, right? The call will just expire worthlessly. So this implies the short position in call options will give you a value of 0. Now, what about the other case? The better case, that is, the share price is 120. Well, in this case, first, your position of one share will give you a value of 120. Now, what about your short position in call option? Remember, you're writing call options. Now, if the share price is 120 and exercise price is 110, the option buyer will want to exercise this call, right? And the payoff, the benefit to the option buyer is 120 minus 110. And this is just the payoff to the option buyer. But you're writing calls, so you're the option seller. So your cash flow should be the negative of the option buyer. So if the option buyer earns $10, you lose $10. So in this case, you should have a minus sign here. But 120 minus 110 only gives you the payoff of only one call. And you have written several calls, right? So you have written X number of calls. So you should write X here. Now this will help us to solve X, right? What is X? Well, it's easy to see that X equals 3, right? So basically you can see that you will hedge this stock position of one share by writing 3 calls, by writing 3 call options with 110 strike price. Now, why this is a hedging portfolio? Well, the reason is because if stock price is 90, this portfolio of one stock and short selling 3 calls will give you $90. If the stock price is 120, then still this portfolio of one stock and minus 3 calls will give you 90. That is, no matter what happens, your portfolio's value is always the same. So that is hedging, right? Now we can actually finally solve the value of this call. Now think about this. Through this hedging portfolio, the portfolio of one stock and minus 3 calls. Oh, here minus 3 calls basically means you're short selling 3 calls, right? Because you're writing 3 call options. So here the portfolio of one stock and minus 3 calls has a riskless payoff of 90, right? Because no matter what happens in the future, it always pays you $90. So this basically means the present value of this portfolio equals the discounted cash flow. What is the cash flow? It's just 90, right? So you discount this 90 with 1.1, and this right hand side should be equal to the present value of this portfolio. And the present value of this portfolio is just today's share price 100 minus 3 times call price. So this solves C equals 6.06. I have to say, you should make sure you understand the second example, because you can see that here we're learning about this hedging. And hedging will actually play a very important role in learning options and futures. And if you will learn about advanced corporate finance, you will learn about risk management. And in that section, you will still learn about these hedging techniques. And when you're talking about hedging, you will use derivatives. Most likely you will use futures. But here, we're just talking about a simple case of hedging. So make sure you understand this simple case. Then in the future, you could understand more complicated case. Okay, so because this is a hedging technique, so we want to define hedge ratio. Let's just define hedge ratio in this example. So here, hedge ratio is the number of shares divided by the number of calls in our example. It's a ratio, so there is a division. And this division is using the number of shares, and this is the numerator, and the number of the call is the denominator. Okay, so you can see that in this example, right? What is the hedge ratio here? If you look at our portfolio, for one stock, you will write 3 calls to hedge against its risk. So you can see here the hedge ratio is given by 1 share versus 3 calls, or 1/3, right? Now, how do you calculate hedge ratio? So basically, hedge ratio has the same formula as delta. Remember, we discussed this replication portfolio, and we defined, or we have this formula which gives us how to calculate delta. So you can see that hedge ratio has the same formula as delta, which is the higher option value minus the lower option value divided by the higher stock price minus the lower stock price, where you could say it is equal to the range of core values, right, divided by the range of equity values. You can try this formula and see this thing actually holds, right? So let's see, how could we check whether this formula holds or not. So what is CU? If you look at this, you can see that CU is, so if the, okay, maybe we should first look at this guy. What is US0? That is the higher share price. Well, it's just 1 to 0, right? And lower price is 90. What is CU? CU is the call option payoff if the share price is 120. Well, our call option has a exercise price of 110. So CU is 10. And this CD is just 0, right? Because you will not exercise your call option. Your call option is out of the money. Oh. So this gives us 1/3. That's our hedge ratio. And you can see that hedge ratio is pretty important, right? Because if you look at this valuation process, what you really need here is this number 3. That is, you really need this hedge ratio. After getting this hedge ratio, then you could find out this $90. And after finding out this $90, you can find out this C, or the call option value. So essentially, right, the hedge ratio is the first step to value the call or put option when you're using this hedging approach, right? Okay, let's see this example here. So you might wonder, what happens if the option is not correctly valued? Let's assume the option is overvalued, right? Because we know that using either the replication approach or the hedging approach, the option value is 6.06, right? So it's 6.06. That's the fair value. And if it's overvalued, let's assume it has a price of 6.50. Now, can you earn some arbitrage profit? Well, you definitely can, right? Because you can see that because the option is overvalued, you will definitely want to sell it, right? You can see that if we continue build our hedging portfolio, that is, we have one stock and we write 3 options. What you can see here is you can see that by writing 3 options, you will earn 6.5 times 3, right? And you will want to purchase one stock at $100. So let's say you don't have enough money, so you would actually borrow the $80.50. So you will use this money with this money to buy one share, and your initial cash flow is just 0, right? And what will happen is, in the future, no matter what happens, you will get this riskless profit. You can check this yourself. For example, if the stock price is 90, then you can see that the call option buyer will not exercise the call. So the value of the call is just 0. And of course, the value of one share is 90. And because the interest rate is 10%, so you have to return this amount. And you can see that you will get this $1.45 positive profit. Now, what about the other case? Well, in this case, you can see that the option buyer will want to exercise the call. And what will happen is the option buyer has 3 calls. So a per call payoff is 120 minus 110, which is the exercise price, so the $10. And if there are 3 calls, the option buyer will earn $30. You're the seller, right? Because you're writing call options. So your cash flow is the negative of 30, right? So you have minus 30 here. And if you add up these three numbers, again, you get $1.45, right? So you can see that this is a arbitrage profit because today you have this zero investment, but tomorrow you will always get this positive payoff, right? Okay, that's for today's